So our next speaker looking at using silicone wristbands to characterize firefighters' exposure will be presented by Dr. Heather Stapleton. Dr. Stapleton's research focuses on understanding the fate and transformation of organic contaminants in aquatic systems and in indoor environments. Her main focus of research has been on bioaccumulation and biotransformation of brominated flame retardants, and specifically polybrominated diphenyl ethers, PBDEs. Her current research projects explore the routes of human exposure to flame retardant chemicals and examine the way these compounds are photodegraded and metabolized using mass spectrometry and identify breakdown products and metabolites. Please welcome to the stage Dr. Stapleton.
When I usually go to meetings, I don't get music welcome me up on stage. So I feel like I'm at the Oscars or the Grammys or something like that. So give me a minute. So I'm here today to talk about some research that we've been supporting in collaboration with the Durham County firefighters. I'm an environmental chemist by training, but I apply my training to the field of exposure science. I'm very interested in understanding the different chemicals we're exposed to and understanding their sources. We are exposed to thousands of chemicals every day. Some of them are beneficial to us, some of them don't impact us, and some of them are hazardous, as we know. And they interact with a variety of other stressors to impact biological responses in our body. So it's important we understand what these exposures are, particularly looking at these mixtures. And as we know, firefighters are exposed to higher levels of some of these hazardous chemicals. But if we want to do something and mitigate these exposures, we have to know the full extent of what these exposures are. And that's something I'm really interested in. In 2019, the Durham County firefighters actually approached the Duke Cancer Institute, and I'm affiliated with the Duke Cancer Institute as well. And they had a lot of questions, many similar to what we discussed this morning. And so we had formed a collaboratory with them and decided to help them answer some key questions. First, to kind of provide more information to them on their chemical exposures, particularly for the firefighters in Durham, North Carolina. And we supported a study using these silicone wristbands, and I'll talk a little bit about that, to help them understand differences in their exposure to different classes of compounds, both on duty and off duty, and particularly when responding to a fire, and what that looked like. And lastly, we wanted them to ask us questions. What could we do to help them most in terms of identifying approaches or methods to mitigate their exposures? So we use the silicone wristband as discussed previously. I think I saw some out in one of the exhibit tables there. These are ordinary silicone PDMS wristbands, but kids get them all the time at birthday parties. They were first introduced as an exposure tool by Kim Anderson's group at Oregon State University and have really taken off in the field. What's nice about them is that when you wear them, chemicals in your ambient environment stick to them and they don't desorb very well. So if you wear them, and typically we have people wear them for about a week or 7 days, it's a nice measure of your cumulative exposure to a variety of different compounds over that period. So it provides a nice assessment of your integrated exposure. And this can provide advantages compared to like a urine sample, because if you measure a urine sample, often you're measuring a chemical that has a really short half-life in your body. So it's really a snapshot of your exposure over the last maybe 24 hours. With this, we can look at exposure over a longer period of time, and we can mail these back and forth. It doesn't require a clinic visit. Plus, from data we've collected, it seems clear that they measure exposures that are occurring via inhalation, but also through dermal absorption and through hand-to-mouth contact. Obviously not dietary exposures, so, but hopefully that's not what we're concerned about in this case. So in our laboratory, when we get these wristbands back, we actually don't analyze the whole thing. We actually take scissors and we cut out a small piece. All right, my animation's a little bit slow here. We take a small piece, it's about 1/5 of the wristband or just under a gram, and we pull off all the chemicals off of that piece of silicone, and we analyze it using mass spectrometry. In this case, we're using a very state-of-the-art mass spectrometer that allows us to do lots of different things. First of all, we can provide what we call targeted measurements of all 150 chemicals. Oh, I lost it up here. Okay, it came back, thanks. For all these different classes of chemicals, flame retardants, plasticizers, PFAS, pesticides, those combustion byproducts, the PAHs. And again, what's nice is we can measure all of these in that one sample instead of having one blood sample for brominated flame retardants or a urine sample for PAHs. We can also do what we call targeted analysis and non-targeted analysis. Targeted means we're running calibration standards. We can get an exact, accurate measurement in parts per billion. Non-targeted means, what are we missing? What else could be on there that we weren't looking for? So we can collect that data and interrogate it a little bit later to see if we can identify what these other exposures are. So if you ever watch NCI or CSI, they're always using mass spectrometry. They make it look a lot easier. You don't get a printout that tells you the answer. It takes a lot longer than that. But it allows us to kind of support those types of approaches. Okay, so what we did working with the Durham County firefighters is we asked them to wear wristbands. We primarily worked with 2 stations in Durham, North Carolina, and we wanted to really look at their exposure profile, their exposure fingerprint during these 3 periods of time, while they were off duty and while they were on duty. And we wanted to actually know what their exposure differences are on duty when they did not respond to a fire, but also on duty when they did respond to a fire. So they would wear a wristband when they started each new shift, which was a 10-day period, 24 hours on, 24 hours off. And so they'd only wear it while they were on duty, and they put it back in the airtight container we provided. They're off for 24 hours, they'd come back and they put it back on. And they would do that for each new shift and then log in electronically whether they responded to a fire or not. So all the firefighters participated over time until they had all 3 wristbands collected from all 3 periods. And you can see a picture of the custom wristbands we made for this project that were black with red lettering and said Durham Firefighters. Okay, so in this, we ended up, now COVID hit in 2020, which really derailed our study. So we ended up kind of stopping recruitment at that point and working with what we had, which at that point was 20 firefighters that had completed nearly all 3 periods. It was 15 men, 5 women. Of those 20 firefighters, 13 had responded to 1 fire event during that period where they recorded a fire event. 7 responded to 2 fires. We also collected information on what type of fire they responded to, and most responded to structural fires, residential fires. Most wore their PPE, and then most were using water to extinguish the fire. Okay, and so we actually provided report backs to the firefighters that participated to help them understand what we measured on their wristbands. So here's just 1 page of the report. It was a little bit overwhelming, I will admit. And it provides information on their different exposures, in this case to PAHs, those combustion byproducts. So you see 4 charts here. Each chart is specific to a different PAH, polycyclic aromatic hydrocarbon. If you start on the left, you see benzoapyrene. That is a carcinogen, one of the most carcinogenic PAHs out there. The measurements are in parts per billion. The blue dots represent the individual firefighters' exposures off duty. You can see there's pretty low, grouped together. The middle and the brown is their exposures while they are working, but did not report responding to a fire during that period. And then the red is the measurements when they were working and didn't reported responding to a fire. So clearly in the red, you can see the exposure levels are much higher, which is what we'd expect, obviously, because PAHs are produced during the combustion process. But what's nice about this design is it allows us to look at each firefighter individually and look at the full difference between these 3 periods and see how those differences compare among the 20 firefighters. So we perform these advanced statistical analyses to look at the full difference using their off-duty measurements as the base point. Right, so in this plot here, again, we're looking at PAHs across the bottom. If you look at that line labeled 1 across, that's like our baseline. That's their average exposure while off-duty to these different PAHs. If we're above that line for the marks, the symbols that say on duty, that means their exposures increase to those chemicals on duty compared to off duty. If it would be below this line, that means their exposures are lower while they're working. What you can see is that all the circles are higher than 1, meaning their pH exposures increased while working, even though they didn't respond to a fire for most of those. If it's filled in, it's statistically significant. The squares represent their exposures while they're on duty and did respond to a fire. So what we see basically is this pattern is that there's higher exposures to pHs on duty, almost overall, but certainly enhanced higher exposures while responding to a fire. For some of those, particularly the benzoapyrene, it's up to 8 times higher. So this was interesting to us because clearly we see the signal from the fire, but I was really surprised that we're also seeing exposures just from being on duty, even though they didn't respond to a fire. So where are those exposures coming from? And I think Tracy's presentation reminded me also that there are those trucks idling, they produce diesel and exhaust, and they do also produce PAHs, so that's possible that could be one source. We did look at all these other different classes. I'm not going to go over every single class, but I'm going to summarize some of the more important ones. I spent quite a bit of my career focusing on flame retardant exposures. These are chemicals intentionally added to building materials, insulation, electronics like televisions, furniture to reduce their flammability, but often they're added in a way that they do leach out over time. So we looked for 16 brominated flame retardants and 36 organophosphate flame retardants. And there's just 2 examples here. I'm not going to make this a chemistry lesson, I promise, but I can't help myself as a chemist. These are both carcinogenic or probable carcinogenic flame retardants. We did report identify exposures in the firefighters. What was interesting is almost all of these, again, were higher on duty compared to off duty. BDE 209 up there, that one was actually higher while responding to a fire and higher just on duty compared to off duty, as was one other one. But what was actually interesting in this analysis, at least interesting to me, is that we monitored quite a different number of flame retardants. Some of them have been phased out due to their toxicity. One in particular, called penta-BDE, was phased out in the US in 2004 due to its toxicity and persistence. It's actually banned in the EU. It's very hard to ban chemicals here, so there was a voluntary phase out in 2004. Well, that mixture was very high in these firefighters, and particularly we could see it was higher at one station compared to the other. In this one station, I've been there several times, it's actually kind of small. Their kitchen, living area, and community work table are all together in a very small area the size of an apartment. So I went back there and I looked at their furniture and I said, how old is that furniture? And they said, I have no idea. Well, these are all hand-me-downs. We don't have a budget to buy furniture. Somebody just donated these and we've had them forever. And I said, can I take a sample of the cushions in that furniture? I'd like to just see if there's a flame retardant treatment in there. And they said, sure. So I opened them up, I took a little marble-sized piece and brought it back to the lab, and sure enough, it had that flame retardant signature in it. So my thought is that probably they got some exposure to this, at least some of their exposure, from just the fire hall itself, from that old furniture. Today, if you go out and buy furniture, there's no longer flame retardants in the cushions because the standards have been changed, because we know some of these exposures are hazardous. So we worked with them to actually get rid of that furniture and get them some new furniture, which were flame retardant free. So that was a really nice outcome. We also looked at phthalate exposures. These are chemicals added to plastics to make them more flexible. They're also in vinyl flooring. Think of your vinyl shower curtain, almost everything that's plastic. They are by far the largest group of chemicals that we measure to which there is exposure. What was interesting here is we saw very little difference in exposure on duty versus off duty. And that might make sense, because that's not something that would change too much from working in the fire station. But what we did see is there was actually 3 small phthalates, low molecular phthalates, that were higher off duty compared to on duty. And these happen to be phthalates that are more commonly used in personal care products. They're actually used to help carry the scent in fragrances. So we think what we might be seeing is that some of the firefighters just had more use of some personal care products off duty compared to on duty, which is what we were observing. But we didn't ask this question. We weren't really thinking about it. We also measured pesticide exposures. There's thousands of pesticides. We have a panel of about 10 in our method. None of those were different on duty compared to off duty, except for this one, permethrin. This is actually a pesticide that's commonly used in a lot of flea and tick medications. And we've seen in our other studies that pet owners have higher exposure to this pesticide. It's actually in this canine Advantix. It's 44% of the material in this flea and tick product. So we think what's possible is that maybe some of the firefighters were pet owners and they had higher exposures at home relative to when they were working, and that explains this. But again, we never asked that question because we weren't thinking about it at the time. And then we measured PFAS. We can measure PFAS on the wristbands. Although I will say PFAS are a big, broad group of chemicals. Some of them are more volatile than others and can get into the air. There's what we call precursors, and then there's legacy. Most of us were worried about the legacy compounds. We did ask the firefighters if they had any exposure or use of AFFF. All said no. They do carry it on their trucks, but they hardly ever use it. The PFAS that we did detect are some of these legacy compounds at very low levels. And the only one that was significantly higher while working was PFOS, which has been seen in other studies. We did actually a study working with IAFF where we measured PFAS in dust samples from fire stations and found in that study also that PFOS was higher in dust from fire stations compared to dust from residences and homes in North Carolina. So we had this one PFAS that was higher. There was another PFAS called 6,2-dipap. That's one of these precursors. It's actually commonly used in food packaging, like the wrappers of your burgers or the insides of your coffee cups sometimes. And it's recently been identified in paint as well. So those exposures were higher off-duty compared to on-duty in this case. So it was interesting, but PFOS was higher on-duty. So what did we learn? We learned that firefighters in this case, we learned a lot about their differences in their exposures, these different profiles. Some were higher, some were lower when people were working. Most firefighters didn't seem to mind wearing the wristbands. It was kind of a pain to take it off when they had the 24 hours on and 24 hours off. That was kind of the only complaint we had. So it seemed to work well for what our needs are. In the future, we'd like to look at answer a few other questions. We know from other studies in the general population that when we measure on the wristbands correlates really well to what we see in blood or urine. But we haven't done that with firefighters, and I think that would be important to do. If you're responding to a fire, you do wear your gear, the wristband's under the gear. We're still seeing these signatures from combustion products, so we think they're working fine, but it would be nice to verify that. We'd also I'd like to understand better if we can see these differences in PAH exposures depending on how close someone is to a fire, particularly if they're wearing their gear or not in close proximity to that. And can we see that difference with the wristbands? And we've also actually started what we call phase 2 of this project with some additional funding from the Duke Cancer Institute. What I'd ideally like to do long term, this will take some time, is to kind of use wristbands like a radiation badge. So you can measure your cumulative exposure to a wide variety of chemicals over time. We have a long way to go because it still is time consuming and expensive to do. But as a first start to kind of looking at this possibility, we're supporting a project with Durham County firefighters where they're wearing a wristband every shift for 4 months. And so we're going to look at their cumulative exposures to all these different chemicals for a 4-month period. And we collected a blood sample at the beginning and a blood sample at the end. And we're going to look at changes in oxidative stress markers and DNA adducts in the blood samples to see if these measurements correlate to their cumulative changes during that, or cumulative exposures during that period. So we're excited about that. We also had 2 questions. This is my last slide, I promise. 2 questions from the firefighters. The first was, can I get exposed to some of these toxic chemicals if I have my gear in the bag and then I put it in my car, or if it's in the cab in the truck? Do these chemicals come out of the gear bags? So we're trying to help answer this question right now. We actually purchased 2 different types of gear bags. We're using liquid smoke that contains PAHs to dose the clothes inside, and we put up air monitors on top to collect what's coming off the bags. So we hope to have that data really soon. We've also been asked a lot about this PF0 gear. Is this really PFAS free or not? So we have some samples of that in the lab right now that we're analyzing. So we hope to have data and answers to these questions soon. So I'm going to end there. Certainly want to thank all my great colleagues at Duke University, the Duke Cancer Institute, and I really want to thank the Durham County firefighters, and particularly Corey Miller and Chief Cheek that helped out a lot in coordinating this study. And I want to thank the organizers for inviting me. So I'll stop there and join my colleague to answer any questions.
Okay, so we'll open it up now for questions from the audience or from online. We'll go over here. Just keep your hand raised and we'll get a mic out to you. And then I'll take questions online as well from our team. Go for it.
I had 2 questions, one for each of you. Did you find any better controls, like did you test trucks with DEF fluid, trucks without DEF fluid? Did you find any better controls? And then my second question will be for you. The PF0 results, do you have any timeline of when that might come out and how you are going to put those results out?
Yeah, it's working. So for our study, we did the diesel engine exhaust measurements. That study has been published, and that is available online. If you need a copy of it, let me know, and I can provide that to you. Unfortunately, we weren't able to look at the effects by different controls that were in place, because there were a large majority of the samples were not detectable. Part of this was due to instrument sensitivity that we had in Canada at the time. So we were unfortunately not able, we just didn't have enough measurements.
Regarding the question about PF0, I do hope we'll have data here the next 2 months. We would, I think, ideally like to publish that data if that's possible. We're talking about doing some additional testing on those materials to make sure we understand and kind of approach it from a broad suite to make sure we fully understand what we're seeing in this material. So the hope is that we will publish it. I obviously can't make any promises yet, but that is our goal.
Okay. Well, Emery, can we have a microphone up here? Oh, I'm sorry. We're going to do one in the back, and then we'll come to you, I promise.
Thank you. I think these exposure studies are fantastic, and I love the study design. I had a question for you, Dr. Stapleton. Was there any way to conduct a recovery study from the target compounds on the wristbands?
From which chemicals, sorry?
From the target, so you did target analysis, but also a screening. And so I'm assuming that
Oh,
you were...
the non-target analysis?
Yeah, so I'm assuming that you did this non-target analysis screening first, and then you identified specific compounds that you were able to measure?
No, we actually can do both analyses at the same time.
Okay.
We can do targeted and non-targeted in the same analysis.
Okay, and so were you able to do any recovery studies from any of the compounds before, just so you know the relative concentration that you're able to extract from the wristbands?
Oh, we can extract everything. I don't know what you mean by recovery. You're just asking whether we're pulling everything off the wristband when we measure it?
Yes, like
Oh, yeah.
for example, like if depending on what type of adsorbent you have, if you have different compounds with different physical chemical properties, they might have a different affinity, and so maybe the wristband is only taking in 50% from the environment and whatnot.
Right. There are some chamber studies out there that have evaluated uptake rates, so we understand how the phys chem properties affect the partitioning and uptake of those chemicals onto the wristband. Basically, the uptake rate is going to be a function of your concentration gradient, right? What's in the ambient environment relative to what's already on the wristband, and also some of the properties like the octanol air partition coefficient and solubilities and things like that. So we do have that data, but I think that it's the concentration gradient that's the biggest driver, which makes sense.
Thank you. I think it's fantastic.
This is like when two scientists talk to each other. That's what you get, right? It's like, okay, all right. Dr. Takichi, Victoria. We'll take one more question, and then...
My question is also to Dr. Stapleton. It's actually somewhat of a continuation of the previous question. At the beginning of your talk, you mentioned that you keep the wristbands on the firefighters for a whole week. Don't they get saturated? I mean, the wristbands have a very finite surface area, and when we do wristband analysis, we usually keep them like a day or two at the most.
Oh, yeah, no. We run them for weeks to months, and they don't get saturated. You have both adsorption and absorption occurring on the wristbands, so we have not seen any saturation whatsoever. Maybe so for some of the really volatile compounds, but that's a function of their volatility that they don't stick in there. So everything we're focusing on are what we call semi-volatile organic compounds. So based on their properties, they're more likely to stick to that silicone and not desorb.
Any other questions we can ask our scientists? Yes, we're going to do one more.
Both amazing stuff. I love it. Different, but amazing both. For the first one, Dr. I'm sorry. Hope everyone heard me before. Both are amazing studies, different completely. One simpler, other one more complex, but beautiful. I love them. I hope everyone is taking water, right? Dr. Stapleton, so yes, it's just a comment. It's interesting to see you have a rate. This study have the sample size 81, and call my attention that is a rate of 3 firefighters for one supervisor.
Can you repeat the question again? I'm sorry.
No, it's not equation. It's an observation.
Okay.
Your sample size is 81 participants, and there is a rate of 3 firefighters for one supervisor. Too many.
The ratio,
Too many
right,
supervisors.
The ratio, she's...
You know? Okay.
Yes.
Yeah, there were a lot of captains and lieutenants who volunteered for the interview.
Oh my goodness, it's interesting. Another one, I love the chart, the graphic you have there. One of the graphics said about researcher observations. That is
Yes.
a good one.
Thank you very much. Okay, we're going to do one question online. This one is for Dr. Stapleton. And it says, have you thought about measuring metals at the same time that you are measuring organic compounds?
Yes, that's a good question, and I forgot to mention it. My lab's organic, so I don't measure metals, but I have colleagues that do measure metals. We've tried looking at them, and the metals don't stick very well to the silicone. They do work better for organics. But with that being said, we are working with some engineers to see if we can adapt part of the wristbands to enhance uptake of metals. And we are hopeful in the future that we could use these for both organics and metals, but right now we cannot.
Thank you so much. Okay, so we're just over time, so I would like for you to join me in thanking both of our scientists in their presentation. And they'll be here all afternoon, so you can ask them questions. Thank you, thank you, thank you.